commence this session. And we do start with a technical presentation at the starting. Once we complete this technical presentation, we are going to see what we are going to learn for the next 3 months here. Okay, I'll be showcasing all the things. Okay. Of course, when we are going through this technical presentation, you can interrupt me at any moment in time and you can keep on asking questions. You will be allowed to do that. Okay, either online people or directly also, you can actually directly, shoot the question out. You can do that. So, some of the sessions which we are going to have, especially at the starting of this, training, are going to be very, very basic sessions, basically to bring everybody to the same platform. Some of you might already be aware of these kind of topics and you might know these contents already, but still you have to bear with us and you have to still go through that content, okay, just to bring everybody to the same level. All right. So now, where do we start with? Because we are going to learn telecommunications and data communications, it is always better to start with understanding how the protocol stacks work. So that is the basic thing we have to start with. All right. So we're going to start with that particular topic itself. All right. So communication models. So before I start the actual session, I would like to add one point here. I want usually the session to be very interactive. Make sure that you participate and try to be active. Very simple as that. So first we start with the known mechanism like human communications. Do you really think human communication follow a layered architecture? And you can ask me, why are you asking this question? Answer for that is very simple. Whatever the protocol stack we are going to learn, all of them are layered architectures. They work in layers. We actually see OSI is 7 layers and TCP/IP is 5 layers. Or wherever we have learned in your engineering days or somewhere in your previous, career, you might have learned this, that protocol stacks works in number of layers. Now we need to ask, basic communication like human communication also works in layers. How many of you will tell yes? How many of you will tell no? Yes. Okay. No. Yes. No. Okay. So we should have a mixed response. And the main aim of the session is to bring everybody to the same note. Okay. So obviously the answer is yes, it is. Okay. It works in layers. So you have basically these many layers if you talk about. So you have got 2 layers in here, application and physical layer. Application is your mind, which is generating the information, that thing that should be spoken, and that should be delivered to the other person, whoever is listening, by using your mouth. Mouth is the physical transfer, to transfer the data from one place to the other place, or from your side to the other side. So you are converting the generated language into a sound wave, and the sound wave is carried over the air interface by making your air is working as a carrier. You are transferring it to the other person's ears. That guy will process it and will try to understand it with his mind. You see? So how many layers we have in here? 2 layers. And the connecting between these 2 human beings is air. Without air, actually this transfer of information won't be possible. It won't work out. Transfer of sound wave. In order to transfer sound wave, we definitely need to have a carrier. So that's the carrier we have to transfer the information there. All right, guys. Okay. Layered architecture or not? Yes, 2 layers. And I have to tell you what is the difference between layers and protocols right away. Here, your mind is said to be an application layer, the one that is generating the information. But what is the meaning of a protocol? Protocol is nothing but, like in case of human communication, protocol is equivalent to a language. Now, this guy who knows English, if he is speaking in English, if the other guy also working out in English, okay, he knew English, he can understand what you are speaking. Otherwise, if you don't know English, he can only listen to you, but he'll not be able to process that information. He'll not be able to understand that information. That is not possible. You see? Are you getting a sense of it? So, have you understood the difference between layers and protocols? In any layer, there can be multiple protocols. For example, at application level, you can be many languages. Each and every language is said to be a protocol. Similarly, do we have multiple protocols at physical level also to transfer the information? Have you got the question? We have multiple protocols to generate the information in different languages. On a similar note, will we have multiple protocols at physical layer also to transfer the information? Yes or no? Obviously, answer is yes. How it works out, I'll tell you. If you look at the bidirectional communication with the previous mechanism, obviously air is going to work out in the middle. Of course, you have to add ears on the left hand side and mouth on the right hand side so that the communication will become bidirectional, two directions. Okay. But whereas on the other hand, if I have to talk about different medium kind of protocols, so what is the scenario? Now this also can work out, isn't it? You are actually generating the information in your mind, but how you are transferring the information to the other person is by using a physical mechanism called as actions. Other person will be able to see it with his eyes. But if you want to see what you are mimicking, we must be in, there must be light so that we'll be able to see each other. Whatever you mimic, other person will be able to see. Here we don't need air interface. Air interface is not required here. Are you understanding? So medium changed or not? Medium is changed. What is the previous medium we have used? Air interface. Now what is the medium we are using? Light. Now in this case, even in vacuum you can communicate to, astronauts. Two astronauts also can actually communicate with each other by using this mechanism, no problem. But two astronauts cannot actually communicate with each other by using the previous mechanism. You see? Are you understanding this? So here we are using different physical protocol to transfer the information. Okay. So now, so that is about human communication, but we need to understand how the communication happens in computers, because that is the ultimate thing we need to learn, because we are learning about telecommunications and data communications, how the communication happens in computer. Assume that we are trying to write a mail, okay, and the content is going to be this. Content is hi, how are you? And you have kept a subject called as hi. That is the mail content, the total mail content, plus the subject, right, which is giving a brief description about the mail content, right? But how do you transfer this information from one computer to other computer? Do computers know English language? They do not. Actually, they cannot transfer the English language from one computer to another computer directly. Why? Computers won't be able to transfer any information in the form of sound waves or languages. Only the information that will be transferred between the computers is in what form? Bits. Okay. So what we should do now? We should take actually this data and we should actually convert that into binary format, ones and zeros. So by using some kind of a mechanism, we convert each and every English character into corresponding number of bits. Normally, if we use a ASCII kind of a mechanism, we'll convert each English character into 8 bits. Okay. Now, this is the content part. which is converted into binary data. Now this binary data, the total binary data is this, if I pack it together. All right. But is it the only thing I need to send it from my computer to my friend's computer? Is it the only thing? Only the content? No. Along with that, what additional details need to be attached? So what additional details need to be attached along with this, along with the content? Who have sent it? What is the to address, from address, what time is sent, what is the subject? Some additional details need to be attached, right? This is human content. This is human input. Okay. Along with human input, there will be some additional input attached by your application as well. Normally, the application which we use for mail generation is called as SMTP, Simple Mail Transfer Protocol, which is going to add additional details. So we are going to attach some additional details at the application level. Now, what is the important point I wanted to tell you here? Computer applications are of two types. What are those? Computer applications which will be able to generate the data on their own. That is one type of application. Computer applications which can generate the data with the help of human beings. Okay. Now, usually your mail transfer application is second type, or first type, which is generating the data with the help of human being. So human being is giving some input. On top of that, this application also is adding some additional input, right? Human being is entering the content, and this application is additionally adding subject, what is the time, from where to where this mail should be sent, these kind of details. Okay, so this is only human input right now. But what about application related information? So your SMTP will attach details like to address, what is the time, what is the subject, these details also will be attached. Again, this also in numbers and English characters, right? We cannot send it as it is. What do we need to do? Even this information also we need to convert it into binary information. So SMTP header also will be converted into binary. So the total information we are generating is this. Half of it is human input, half of it is attached by your application intelligently. Application has got that intelligence. You see it, right? Now, how do we transfer this information from one computer to another computer? Actually, if you can give this information to the application, SMTP application present in another computer, that application can actually display this information beautifully, because you know the logic, you know how to convert this binary information back into English language or numbers, you know the rules. So you will be able to convert it back and present it to the human being who is sitting in front of that computer. But how do we transfer this information? So assume that if two computers are directly connected, now this is how we are actually having the number of layers. So what are the layers we are having? SMTP is your application which is generating the data in what form? Binary. That binary data is actually sent to physical layer. This physical layer is actually connected to the physical layer of the other computer by using a direct cable. Okay. And on this physical cable, the actual thing that can be transferred is electricity. But how do we transfer our actual binary information? Very simple. How do we transfer the actual binary information? Wherever you see a 0, we are going to generate a negative electricity. 0, negative electricity. 0, negative electricity. 1, positive electricity. Very simple. That is the rule at your physical layer. Zeros are negative electricity, positive, positive voltage is 1, negative voltage is 0. As simple as that. Okay. Now, this rule is known to both this physical layer as well as this physical layer. Which electricity should be which voltage should be converted into what information. So what this guy is going to do, this physical layer is going to do, whatever the information he has gathered from the physical link, he will start sending all that information to application. Whatever application will do, will present that information to the human being who is sitting in front of a computer, isn't it? So how many layers we have here, guys? How many layers we have here? Actually speaking, exactly like your human communication, right? How many layers we have? Application, this is, and we have application here in the other computer as well. Okay, and application is giving the information to physical layer, which is physical basically, and physical is the one which is having a linking, and the information is getting transferred from application to application. So number of layers we have in these two computers are 2. Okay. Now, so what is the comparison between human communication and computer communication so far? In human communication, whatever the information generated is getting converted into either a sound wave or an mimic action. Okay. Other person will be getting that sound wave, or he is actually seeing whatever the action you are making, and he is converting that into corresponding information and process it by his mind, his application. But in case of computers, the information is getting converted into binary data. That binary data is transferred from one physical layer to another physical layer with the help of what? Cables with electricity. That is a comparison. All right. But the question that comes into our mind is, if this computer communication is so simple, like just having 2 layers, why we have learned in our engineering days, or why you have learned earlier, that your computer communication is going to comprise of either 5 layers or 7 layers? Why these many layers are required? Actually, no. If you actually look at it, we have the physical layer and application layer. Till now we have discussed about only these 2 layers, application and physical. What these layers are doing in here? Presentation, session, transport, network, and data link. What these layers would do? Why these many layers additional? In the previous case also, communication is working out or not working out? That is the question. Is it working out or not working out? It's working. Information is getting transferred from one application to another application. Then why do we need these additional layers? What do you think? Any input from your side? Give a guess. Anybody can participate, even online guys. Yes.
For security reasons.
For security reasons. Okay. Okay. Some point. Good. Yeah, Kapil, go ahead. Yes. Okay. So whatever answer that is told by Devabrat is actually the correct one. Basically here, he has given an answer called as extra functionality. Okay. So basically, why do we need these many layers is to bring in additional functionality. Each and every layer is going to bring some extra functionality. That is the actual point. Of course, one of the person has told that, Sneha has told that it is for security. Of course, security is also a functionality, right? Which will be, operated by one particular layer. So every layer is bringing an additional functionality. That means your actual communication, computer communication is not as simple as the picture that we have seen in the previous slide. In the picture we have seen in the previous layer, what was the scenario? Computers are directly connected with each other with a piece of a cable. Direct linking. Do you really think that your computer will be connected directly with a piece of a cable to a friend who is, there in New York? Yes or no? No. You will be connecting to routers. Basically, computer communication is going to be a linked communication. So in order to bring in additional functionality, we require these layers. Is that point clear? Now there is a connecting point to that. which we need to think. Let me tell you this. Out of all these layers that are present here, only physical layer is related to hardware. Okay, which is going to convert binary information into electrical pulses, which is related to hardware related tasks. But rest of your layers, if you look at it, application to data link, all these layers are software based layers. That means they will be running as a software in your computer. Okay, they're all software based. They are logic constructed. They are working on a particular logic according to the program that is designed. The point is clear or not? Now my question is this, listen to the question carefully. If all these are software layers, why can't we generate one single software which is doing all these functionalities? Can we generate or can't we generate? If one software itself is doing all the functionalities, then ultimately we are going to have how many layers? Just two. This whole thing is one software which is doing some n number of functions, and the physical layer which is doing its duty. That is definitely a possibility. Yes, you can generate the software as a simple program. You can generate one software which is doing lot of functions, including lot of functionalities into it. But if that is a possibility, if all these layers can be generated as a single software, for what reason do you think they have actually segregated these layers and showing them differently? What is the reason for that? Significance is fine. I am not denying the significance there. What I am only telling you, that why can't we generate all of it together? It is very simple. If you are writing a C++ program, for example, you can write a C++ program to generate Fibonacci series and to write the prime numbers, to generate the prime numbers. Okay, in two separate programs, or you can do one program itself which is doing both. By doing both, you see, you can generate. So similarly, on similar lines, I'm telling you, why can't we generate the functionality in one software, and you don't need to call them to achieve modularity? Okay, that's definitely good answer, to achieve modularity. But what is the reason? Actually, see, if you look at operating system, do you think operating system is a very complex software or not? Yes, very big and complex software. Obviously, we are just calling it as operating system, Windows or Linux, isn't it? On the similar lines, okay, so it can have all the functionalities generated in one software. What is the advantage of modularity? Efficiency? No, efficiency is never an answer. To support? Okay, you are almost near. I understood your point, but others should understand. The presentation should be that way. You are near. Try to enhance that. The answer is this. For example, I'm just telling you general example here. You are actually writing a letter to one of your friend who is present in Kolkata in Bengali, and you're posting that letter. Okay, you're posting that letter into a post dabba, and the letter will reach your friend. But do you really need to, do you really think the postman also should know Bengal or Bengali language? He doesn't need to, because you're going to write the address maybe in English language. He will read that and he'll just forward it. You don't really bother about reading the contents inside the letter. That content may be there in Arabic, or it can be there in, Latin, it can be there in Persian. You don't know what is the content, but his only duty is to do what? He must be able to understand the to address and from address, and he must be able to forward that. That's all. That is the only story. You see? Similarly, in your computer communications, do you know that there will be some components called as routers? The duty of routers is they never should be reading application information. What they should be doing? Router should be forwarding your IP packets. That's all. Routers only should be forwarding the IP packets. Now, if your application data is made by the application, it is packed into an IP packet. Okay, your routers will be reading only IP addresses and will be forwarding that IP packet to the destination. But in which layer this IP address is going to be attached? At what level this IP address will be attached? At what layer? Usually at network layer. Okay, network layer will be attaching the IP address. Now the story is your router should be containing only up to network layer. Okay, it should be containing only physical data link and network. Router never need to contain anything above transport, not required. Okay, why? Because router requires only up to network layer, must be able to read only IP address of that data. He must be able to forward that IP packet. That's all. He doesn't need to read the information or the functionalities implemented by the above layers. You don't care. Understanding it? Now, if you generate the software as a single software, you will not have the availability to install. If you install that software everywhere, your router also can understand application data. Is it required? We don't require that. We require only the required layers at router. We don't require every layer at every component. On a similar note, if you take switches, what are those? Switches, which work only in the local network, they will be operating with only two layers, physical and data link. They won't even need to have network. There will be one more component called as repeaters, which will basically enhance the signal strength, which will receive the signal and enhance the signal strength. Meaning is they will basically, amplify the signal and send it on the other link. Such kind of components don't even need to have data link and network layer also. They will be only operating at what level? Physical level. That means in the network, lot of heterogeneous devices will be there, which will be operating on different levels. They need to have only that particular layers. Every component doesn't require every layer. Not needed. Okay. That is the exact reason why they have kept these layers separated, such that we can install the required number of layers into required components. You understood that point? Is that getting clear? So just like whatever the example I have told you about postman. You see, postman never need to know what you have written inside the mail. You don't care about also. Postman only worry about how to forward this letter. In which box I need to put or in which van I need to put. That's all. He'll be worried about that. Okay. Now, one more important point here. Okay. In the routers, we'll only have network and data link and physical. Fine. But about transport layer, I have to talk about about transport layer and all that. Okay. Now, look at this point. This transport, session, presentation and application, these four layers will be present only in client computer and server computer. What is it? Client and server. These four layers, which are those transport, session, presentation and application. Clear, guys? They won't be present in any middle devices. They will be present only in client and only in server. If they are only present in client and only present in server, can't we at least combine these four things and make it into one layer? Yes or no? Obviously answer is yes, isn't it? Answer is a yes. We can combine them because they are present in only two components at the source and destination, that's all. But why they have kept these four layers separate? So it is meaningful to actually understand physical data link and network should be separate because only physical we need to install in repeaters, physical plus data link we need to install in switches, physical plus data link plus network we need to install in routers. They are meaningful to be kept separate, but what is the logic behind keeping transport, session, presentation and application also separate, even though they are present only in client and server? Okay, each layer has its own functionality. That is absolutely correct. There is nothing wrong in it, that statement. But can't we generate all that functionality together as a single software? That is the question I'm asking. We can, no? Because it is only present in client and server. In client, there can be one software which is doing application job plus presentation job plus session job plus transport job. One application which is doing all the four jobs because it is doing in client, and the reverse job should be done in server. Server also will contain similar application which contains all these functionalities together. We have given the justification to below three layers. Now we need to give justification to these four layers, why they have kept separate for these four layers also, isn't it? Answer is in each computer or each client and server. I have introduced about protocols, right? Now that protocol is the word which is going to be useful here. There can be many presentation protocols, x number of presentation layer protocols. There will be y number of session layer protocols. There will be z number of transport protocols will be present. Okay. Now, why they have kept separate is so that one type of application will choose one type of each protocol inside these layers. Okay. If you combine it and generate only one application with all the functionalities together, then you will never have any kind of flexibility. There is no flexibility to choose. You develop that application yourself. I will tell you the second reason also. For example, in the transport layer, there is two famous protocols called as TCP and UDP. You remember it? Okay. Now, you might have heard this TCP UDP somewhere in your life. These are two different protocols present in transport layer. Usually this TCP and UDP protocol, how that protocol should work, all that functionality and the mechanism is already implemented into your software, implemented into your operating system. So operating system knows how TCP protocol works, how UDP protocol works. Okay. Now, if you are designing any application yourself, now you need to only decide whether your application is going to use TCP protocol or UDP protocol. You don't need to generate the logic for TCP or UDP. You need to only choose it. Choose from where? Choose from operating system. For example, if this mechanism is not separately implemented and it is not implemented in your operating system, okay, TCP and UDP is not available in your operating system, what you should be doing when you are designing your application? Along with your designing your application, you need to write the logic for what? TCP logic or UDP logic yourself. You need to write it and you need to generate that whole application as the full application yourself, everything, all of it. So application logic you need to generate, presentation logic you need to generate, session logic you need to generate, transport layer logic also you need to generate. transport level logic also you need to generate. So all the layers logic you will be generating. But what can happen now? What is the scenario nowadays in the actual computer communications? Most of the times, all these layers, functionalities or the protocols already present in your existing operating systems like Windows and Linux. And in each operating system, there will be different transport layer protocols present. There will be different session layer protocols. There will be different presentation layer protocols already present in your operating system. What do you need to do now? If you are designing your application, from your application, you will write the logic of only choosing which one you want, which presentation you want, which session you want, which transport you want. If you choose, that will be enough. Automatically, that functionality will be attached to your application. Of course, when there are different protocols, no, each protocol will be working differently or not. Now we need to understand which protocols will do what job, what is the specialty of each protocol, which kind of applications will choose which protocol at what time. That we need to understand. But by dividing and keeping these layers, we will be having the flexibility to choose which protocol to be picked up from the available protocols of each layer. Are you understanding it? So that is the exact reason why these 4 layers are kept separately. You see? Okay, transport, session, presentation, and application. All right. So if you are generating application on your own, so what you're going to do now, if you are generating application on your own, you will just pick this one and you will pick this session, you will pick some transport like that. Okay, so if there are many things available here, right, many things available here, you will be choosing like that. You see, you will be picking this protocol in presentation, this protocol in session, this protocol in transport, and you will also have the flexibility to ignore one layer if you not required. Okay, ignore any layer if not required. If you don't think that functionality is required for you, what you can do, you say ignore kar, I don't need this. I will tell you example. This presentation layer mainly does something called as security, which somebody has told to us previously. Sneha has told us. Okay, security. Now, for example, if you are opening a website called as Times of India, now do you really think Times of India website need to be downloaded from Times of India web server to your computer securely? Is security required? Not required. Why? That is a general website. Anybody can open and see that. There is no secret in it. Anybody can open it. So there is no security required here. In such case, no, you don't need to use your presentation layer. But if you are opening your bank website, okay, whatever the information or whatever the communication that happens between your computer and the bank server must be secured. That time, your Mozilla Firefox must be using presentation layer. In the previous case, the same Mozilla Firefox will skip presentation layer. Why? Because you are opening just a newspaper where security is not needed. So same application, guys, which is Mozilla Firefox or Internet Explorer, in one scenario, it is using presentation layer. In another scenario, it is bypassing presentation layer. It is ignoring presentation layer. Are you getting a sense? Understanding it? So just to have that flexibility, when applications want to choose the required layers or which protocol in that layer we want to use, they have kept these layers separately. But these 4 layers will be present only in client and server. Okay, transport, session, presentation, and application. They won't be present in routers or the middle components. Middle components are only going to contain only physical or physical plus data link or physical plus data link plus network, depending on whether they are repeaters or switches or routers. clear? Guys, whatever that you are seeing in front of your eyes, is it OSI protocol stack or TCP/IP protocol stack? OSI, because usually OSI is the one which is having 7 layers. But normally TCP/IP protocol stack will be containing usually only 5 layers. What are those 5 layers? We have physical, data link, network, transport, and application. So if you have only these 5 layers, so are we ignoring this presentation and session completely in TCP/IP model? Are we ignoring those 2 layers? No. What is the scenario then? They're attached with application. If the presentation and session is tightly coupled with your application, so it is fixed now. So there is no way of doing choosing the flexibility now. Okay. So if one particular application decided to use one particular presentation mechanism which is already linked, one particular session mechanism which is already linked, there is no way you can escape from that. That is tightly coupled already. That linking is already done. So you will not be able to separate that out. In such scenario, the whole thing together will be calling it as what layer? Application itself. Of course, some TCP/IP applications may not use presentation and session. Whether they use or not use doesn't matter. But what is the concept I'm telling you is, if at all they use presentation and session, if those presentation and session layer logic is tightly coupled with your application layer logic and the flexibility is no more there, it is fixed, in such kind of scenario, that particular stack is what we call it as TCP/IP model, where we are going to have only 5 layers. Okay, so this whole thing is your application. Then we are going to have transport. Transport is always separate, whether it is TCP/IP or whether it is OSI. Transport should be separate, should be present separately. Okay, only presentation and session can be coupled with application. Okay, so if it is coupled, it is 5 layers. If it is not coupled, if they are separate, okay, we are just linking them temporarily for the purpose of achieving your task, then we are going to call it as 7 layers. Are we clear? Now, what we are going to do in our next class, I will tell you, but before that we have to see this. This is a very important slide. Every application, every layer, what is the job it is going to do? We know that every layer is actually doing a particular functionality, yes or no? To achieve that particular functionality, every layer is going to attach some header. That application, if application layer generates the data with or without the help of human being, and he is going to attach some header. Why that header is required? The header is nothing but some additional information. That additional information is useful for your actual duties. For example, if you put your normal letter into post office, okay, if you put a normal letter into your post office, is there any delivery guaranteed for you? No, delivery is not guaranteed. But if you want your delivery to be guaranteed, what do you need to do? You need to put it in some DTDC or some courier service. They will give you one tracking number or not. With the help of the tracking number, you will be able to track where your letter is and all that. This tracking number is additional information or not? It is. That tracking is actually used for some additional functionality. Yes or no? What is the functionality? Reliability. Similarly, if every protocol is performing some functionality, to achieve that functionality, every protocol must attach, every layer must attach some additional information. That is what we call as header. Okay. So application data either independently generated or with the help of human beings. For that we are attaching some header. Okay. Then that information is sent to next layer. which is that presentation. Presentation is also doing some functionality or not? So what is he going to do? He is also going to attach some header to perform its duties, again converted into binary. That whole information will be sent to session. Session is also doing some functionality. He will also attach some header. That header again will be converted into binary data. The whole thing will be sent to transport. Transport also attaches some header and converts that into binary, and that whole thing will be sent to network. Network will attach some header and is going to convert that into binary, so as data link will attach some binary information. The whole thing is what we send it to physical layer. Usually physical layer is not a layer which is not going to attach any header. The duty of physical layer is take this full binary data, in that all the layers headers are present, okay, and he is going to transfer this to Lokesh. You have any question, Lokesh? You have unmuted your mic.
Oh.
Yeah. So physical layer is going to transfer all this data in the form of what? Electrical pulses sequentially, like 1 1 1 1, all positive pulses. Like that you will transfer it. The other system's physical layer receives it either directly or with the help of middle components, if middle components are there. But I just want to show you what protocol layers are going to do. Now, once data link layer receives all this information, can you please tell me what is he going to do? He will read how much part of this whole thing. Data link layer will read how much part. What part he will read in the whole thing he has received? Come on. Only the header part. Only which header? His header. He is not going to read everything. He is going to read only his header. And after reading his header, he will remove that header before he forwards the information to network layer. You see? Why he is removing his header? There is a twist there. For example, if some company's CEO is getting a mail, okay, he will actually try to read the contents. He will never try to read what are the postal stamps. Postal stamps are unnecessary for him. Postal stamps are added by the postal department. That is only useful for postal department. Nothing is useful for the person who has received it. So data link layer header is only useful for data link layer. It is not useful for network layer. There is no point in forwarding that header to network layer. So data link layer will read that header. Whatever he is supposed to do, he will perform that functionality. After performing that functionality, data link layer is going to forward only the remaining portion of the information to the next layer. You see? Okay. Now give a guess what network layer do now. Network layer is going to read his header part, perform his own functionality. After performing his functionalities, it will remove its header and forward the remaining amount of information to transport layer. Because everybody is doing some functionality here with the help of what? Header. So transport layer is doing the same, removing its header part, forwarding it to session. Session is doing its header part, forwarding it to presentation. Presentation is doing its header, reading its header and removing it and sending the remaining thing to application. What application will do? He will read his header and his data, convert it into human readable format, into some English language or Russian or whatever, depending on the information received, and he will present that to the human being so that human will understand that. See, ultimately, whatever the information human is sent, the other human is going to read only that part. All these headers are only for the temporary sake, only for the purpose of achieving the functionality of each and every protocol layer. Are you understanding the concepts, guys? Okay. All are basic concepts. I'm not telling you rocket science here. I'm just telling you some common features of these protocol stacks. Okay. Now, what we are supposed to do from our next session, we need to understand what is the main major functionalities of each and every layer. Okay. Every layer is going to perform some particular functionalities. For example, if you look at only physical layer, what is the physical layer functionalities? We need to study that part. What are the physical layer functionalities? Like representation of the bits. Physical layer is worried about how to represent 1, how to represent 0. 1 is represented in positive voltage, 0 is represented in negative voltage if he is using electrical cable. Okay, if he is using optical fiber cable, he will be telling that 1 will be sent with one angle, 0 will be sent with another angle. You see, he will be dealing with angles in case of optical fiber, because we will be sending a light wave in an angle. Based on the angle, you will understand whether that is a 1 or 0 in case of optical fiber. Okay, so physical layer worries about that. Plus, physical layer worries about data rate. Data rate is always linked with what? Cable speed. Cables can be of different types. For example, if there is a Cat5 cable which can transmit the data at 100 Mbps speed, 100 megabits per second, that means even if the data link layer is giving 100 MB of data, that 100 MB of data can be sent out in 1 second by converting it into 100 mega symbols. Symbol means one pulse, one electrical pulse you will be generating. So Cat5 cable is capable of sending 100 MB of data per second, whereas if we use Cat5e cable, it will be able to send 1000 Mbps. So this basically tells us how much amount of data physical layer can attract from data link layer per second and how much he can dispatch, isn't it? This is the capacity of the physical layer. Understanding? Transmission mode. For example, if we are using copper cable and fiber optic cable, copper signal, if you are using copper cable, your electricity will be used and your voltage will be getting deteriorated. It will be losing its stamina while traveling. Every 2.5 kilometers at least, you must be using an amplifier, repeater to enhance the signal strength once again. Okay, so if we are using copper cable every 2.5 kilometers, we need to have some repeater to enhance the signal strength. Physical layer worries about this. But whereas on the other hand, if you are using optical fiber cable, the signal won't get deteriorated up to 250 kilometers. Only every 250 kilometers we need to have the repeater or amplifier. Are you getting it, guys? Are you understanding that? Now, how the physical devices are connected? Devices can be connected in different modes, like bus topology. Everybody is connected to one bus, or everybody is connected to a middle device. That is what we call as star. Bus means like this. Every device is connected to this bus, like that. Okay, that is bus. What is the meaning of a star? All the devices are connected to a middle component, like a switch. That is star. Or mesh. Mesh means everybody is connected to everybody else. That's called as a mesh architecture. So physical would need to worry about in what kind of a architecture it is using to connect between these components. You see, it's all about what physical layer is worrying about, his own story. If I get the data, how to convert the data into transferable information, how fast I can send it, at what distance I need to use repeaters. See, he is worrying about only his functionalities, physical layer. But physical layer won't be attaching any header. He's going to take the data from data link and just send it, that's all. Similar to physical layer, we need to understand the functionalities of each and every protocol layer, which we are going to, each and every protocol layer is going to have lot of functionalities, which we are going to understand in our next session. We'll not be able to complete it if we start it, but anyhow, I have to introduce to you the course content and various other details. We have to speak about. That is why I'm stopping this technical content, but I'll show you one slide before I stop in here. After we study all these protocol layers, then we need to actually learn different protocols which work at different layers. Like what? At data link, what protocols we are going to learn. At network, what protocols we have to understand. At transport level, what protocols we need to understand. At session and presentation, and at application. Different protocols, different, protocols for different purpose. We need to learn these protocols. Once we see the general functionalities of all these layers. Okay. All right. So for now, I'm quitting this and I'm going to show you two contents for you. Advanced telecom protocol testing and development content, and as well as L2, L3 protocol testing and development content. Two things I'm going to show you. So the very first module which we have started right now is data communication fundamentals, nothing but your OSI fundamentals. And the session we had today is related to introduction of data communications. In this session, we are going to learn different things at different layers. We are going to learn. This will typically be taking 14 to 16 sessions for us. For the first 14 to 16 sessions, we'll be finishing out this OSI module. Okay. Once we complete this module, this OSI module, you will be thorough about computer communications and you will be able to capture the traffic which is going out of your computer and you will be able to understand what information is going out of your computer. You will be able to do that. Okay. For this OSI module, as part of the practicals, you will be learning two tools called as GNS3 and Wireshark. You'll be learning two tools and practice these OSI mechanisms, okay, your TCP/IP mechanisms by using these two tools, GNS3 and Wireshark. Of course, these are open tools available in the open internet. You can also download it and install it. But what I am going to teach is, I will teach you how to use these tools, how to work with the tools. How do you create the environment with the tools? For example, if you take GNS3, so you will be having a GNS3, you can actually take this GNS3 tool and you will actually be taking like routers, okay, and you will be taking like switches, and you will take some computers, okay, and multiple computers you can drag and drop in, and you will be able to connect between these computers to switch, this computer to switch. We will be connecting it that way, and we will actually try to capture the traffic by using this which software? Wireshark. Okay, what is the traffic going on between these computers? We'll capture it with Wireshark and we'll analyze it. We need to understand those protocols. We need to study those protocols. We need to study the information present in the headers of the protocols. Okay, but to analyze that protocol information, which tool is going to be helpful for you? Wireshark. So by using this Wireshark, you will be able to capture the information going out of any system. Like for example, I can actually capture the information going out of my system right now, okay, by starting this traffic capturing. Right now I am speaking and I am showing the screen. Online guys are getting my voice as well as the screen, right? So what is the information my computer is sending to all these online guys? This is that data right now, which is being captured. A lot of information, you see, right? But you must be able to capture it and understand that protocol headers, that protocol information. What is that protocol information? That is our primary goal. So first, once we learn these protocols, okay, so once we learn these protocols, we'll be simulating those scenarios with GNS3 and capturing it with Wireshark, and we study those things. So what is the main aim of this first module? You will get very sound knowledge about how the computer communications happens, you will never get a doubt in your life about how computers are communicating with each other. Okay, how these protocols are working for general computer communication. And this one module is going to be common for people who are attending LTE protocol testing or L2 L3 protocol testing or development, LTE protocol development or L2 L3 protocol development. For anybody who is going to take up these sessions, this module is going to be same, this part, first module. So for the first 14 to 16 sessions are going to be common for everybody. LTE protocol testing development, L2 L3 protocol testing development. After that, teams will be separated, LTE people will be separated, L2 L3 people will be separated. Okay, what LTE people are going to learn, I'll show you first, then I'll show you what L2 L3 people are going to learn. Okay, now LTE module. The LTE module consists of introduction to wireless telecommunication fundamentals, that is introducing 2G and 2.5G. Okay, introducing only. Within 5-6 sessions we'll complete this out. There is nothing we need to learn here, just introducing, because this technology already has become very old. We are not going to get a job on 2G or 2.5G. We are not learning it, but we are learning it just to get a fundamental understanding of telecommunications, especially wireless telecommunications. Okay, after completing this, on the similar lines, we will be learning fundamentals of UMTS and HSPA, even fundamentals of this. This is called as 3G and 3.5G, even fundamentals only, because even though we are not even going to get the job on 3G or 3.5G, this is also has become old, only fundamentals. All right, and the final thing, once these fundamental concepts are over, you will build the required basic knowledge for wireless telecommunications. You have built the basic knowledge. With the help of those basic knowledge, we are going to start our actual module, which is LTE, long-term evolution. So in LTE, we'll be covering all LTE architecture, LTE network elements, nothing but what are the components we use in LTE, what is the protocols we use in LTE, what are the interfaces we have in LTE. We'll be studying them thoroughly, including the call scenarios, handover scenarios, everything. We'll be learning them very in depth. This is the actual module on which you are going to get the jobs on. This is the theory and this is the part which we need to really concentrate and learn. Of course, doesn't mean that the other ones are not. Other ones are very much required to get to this level. Okay, but once we complete the basic LTE, we'll be covering advanced LTE topics like VoLTE and IMS, voice over LTE and IMS. Okay, these are advanced LTE, these are called as. Okay, so that topics also will be covered for you, including all the IMS call flows and scenarios, and you will be covering a protocol called as SIP and SDP, VoIP and SIP. That part also will be covered here. Okay, so this is going to take the major chunk of our time. By the time we complete this LTE part, we would have already passed around 2 months to 2 months 10 days. We would have passed it already. Okay, so in the first 2 months 10 days, we'll be covering up to what part? LTE, advanced LTE section. Okay, so once we complete this, our theory part has got to come to an end. We are ended the theory part. So what we are going to start now for the next 1 month is going to be your practicals on LTE protocol testing or LTE protocol development. First, I am going to show you the practicals for LTE protocol testing. I'm going to show you. Okay, for this LTE protocol testing, you will be learning a scripting language called as TTCN3. And why we are learning this TTCN3 scripting language? This TTCN3 is a scripting language standardized by 3GPP. 3GPP is the body which writes the standardization documents for your LTE networks. Just like IEEE and IETF. Have you heard of IEEE? Simply like IEEE, we have another body called as 3GPP, which is which is there to write these specifications, how these protocols should work. Okay. So if you want to find that out, you can actually go to the ITSI website. ITSI is a European Telecommunication Standard Institute, which is part of 3GPP. And if you go to this website, you will be able to see that. Okay. So 3GPP has standardized this TTCN3. This TTCN3 is that. So what are the TTCN3? Once we learn TTCN3, we need to start writing the test cases in it, and we need to execute those test cases. But to execute those test cases, we need to use one of the tools that are listed here: Confirm IQ, or Devo Team, or LVA Testcast, or OpenTTCN, PragmaDev, or Testing Technologies TT Workbench. One of these 7 tools we need to use to test those LTE test cases. So that means if you are learning this particular LTE protocol testing, you must have one of these 7 tools. But these 7 tools are pretty much costly for you. If you go into this, for example, Elvier, you will be able to see the pricing. It is around 9,000 euros, which is around 8 lakhs. Okay. You won't be able to actually see this tool used by any other institute in India other than TCLOUD. Okay. And you can get a doubt that why we are having this tool. Okay. And we are having it because we are partners with this company called as Elvier. Okay. Which is a Estonia based company. Right. So we are partners for them. So partners in India, Asia. Okay, so this Elvier, who is this Elvier? Elvier is a partner for 3GPP, and they develop these TTCN3 tools required for telecom protocol testing. Okay, and this is one of the top 2 tools in the world. The top 2 tools in the world are Elvier Testcast, and the second tool is TT Workbench, developed by a company called as Testing Technologies, which is also from Europe, but from a different country. Okay, this is a Estonia based company, Elvier. All right, so you can find those details from about us. Actually, if you go to see the address or whatever, you'll be able to see those details. It is in Estonia. Okay, so so we're having tie-up with that. That is why we are getting the tool Elvier Testcast. You see that? Testcast T3, that is the tool we use for doing those testing. Okay. And usually because of this cost and because of this thing only, nobody will be having it. That is the reason usually TCLOUD people will tell that whoever have called you, or normally even we tell about openly. If you find out a live lab for LTE anywhere in India, in any other institute, we give this course for free of cost, because we are damn sure that nobody is having it. We know the market conditions. Okay, that's the reason, right? And this is the first tool, and these are some snapshots for the tool. Okay, now this is the snapshot of a IMS test case execution showing that it is passed. All right, and now after that, what the tools that we are going to have? TCLOUD is a software company plus a training center. We do corporate trainings as well as normal public trainings, just like this session. And we do develop the products also on our own. And we have developed around 4 LTE related tools ourselves. And we have sold it to 2 companies, Wipro and Freescale. And these tools are being used in those companies, actually. These are our own developed tools. Okay. I won't be able to show you these tools in today's class. I'm going to show you these, demonstrate these tools to your eyes directly. I'll open these tools and show you in tomorrow's class. I'll introduce this. But here I'm just introducing the tools. I will show you the tools in tomorrow's class, right? First tool is called as LTE functional tester, by using which you can actually do LTE functional testing. Okay, so this is the LTE functional tester tool. Okay, snapshots. You see the snapshots now, you will see the actual tool tomorrow, right? So these are the snapshots of executing LTE testing, right? Which are developed by TCLOUD. Okay. Now, this is one tool. The second tool is LTE load and performance tester, again developed by TCLOUD. And these are the snapshots of that tool to, to be able to create an LTE network and to execute the test scenarios on that. Okay, to connect those components and to execute the test scenarios and study the protocol logs and analyze the test cases. All right, and this is another snapshot of that. For example, like 100 UEs are completing an attach procedure in LTE network. People who are in telecom already can understand what is the meaning of attach. Attach is simply equivalent to your mobile is registering with network. Okay, so 100 mobiles are registering with the network at once. We have executed that scenario here. And the other tools developed by TCLOUD used for different purposes are LTE protocol coder and decoder. This is that tool snapshot, which I'll show you again tomorrow. And there is a HSS developed by TCLOUD, which is basically LTE database, HSS called as. That tool also we can use to practice and understand LTE scenarios. Okay. Now these four tools are developed by TCLOUD. So LVR Testcast and these four tools. Now, all these 5 tools, you can only use it on TCLOUD Lab. Direct, for the people who are attending these sessions directly, you will be able to access the lab in our lab and use these 5 tools. LVR Testcast plus tools developed by TCLOUD. But for the people who are attending online, also, you can actually connect to our lab servers by using some credentials which we give, username and password, with which you can connect to our lab server and you can use these tools. These 5 tools cannot be installed on your PCs. These 5 tools will be working only on our lab servers. Okay. Now, previous 2 tools I have introduced along with OSI, Wireshark and GNS3 can be installed on your PCs also. You can work out. But for GSM and UMTS, we are not doing any practicals. But for LTE practicals, you need to be connecting to our lab servers. Clear, guys, so far? Next. Along with TTCN3, the additional scripting languages we support at TCLOUD are Perl, Python, TCL, and Shell. If any one of you wanted to learn these scripting languages, you can learn. Okay, Perl, Python, TCL, or Shell. So basically at TCLOUD, we are experts of data communication courses, telecommunication courses, and as well as scripting languages, different scripting languages. So we have experts available for each of these scripting languages, because normally by using scripting languages only, most of the development teams and testing teams will work. Okay, so that's why you need to learn one of these famous scripting languages to be able to get a job. So TTCN3 is one thing. These are additional, out of which you can choose one. Okay. At the end of it, we are going to understand what are the different functional testings and how to write the telecom test cases. And along with that, you are going to learn Quality Center and SVN. These Quality Center and SVN tools are actually used for both development people who are learning development, who are learning testing as well. These 2 tools will be covered. Of course, these 2 tools also are freely available tools available in the internet. You can download them and install it and use it. We will only teach you how to work with them. What do you do with them? How to work with them. Okay. Quality Center and SVN, right? But these are all testing related concepts. Okay. So what about development? Till now, whatever the practical part we have seen, that practical part won't be there for developers. So after the first 2 months, 10 days, again in LTE, 2 batches will be formed. LTE development will be separate, LTE testing will be separate. People who are choosing LTE development, they will be working on mainly 4 parts. Okay, that is protocol, codec, decodec development. Second, protocol state machine development. Third, okay, socket programming. Fourth, okay, protocol logic building. So there will be 4 subsections in your development. So by using one of the development languages like C, C++, or Java, whatever that you choose, by using that language, we will teach you how do you develop protocols. What are the finer parts of the protocols? What do you need to develop as part of the protocols? So these are the 4 sections that will be covered. And you don't require to use any tools for development. Reason is, for development you need to only have what? Compiler. Once you have a C++ compiler, you can generate the code. But if you wanted to find out whatever that you have developed is correct or not, what you can do is, we have all the protocol stacks developed for our tools. What you can actually do is, if you can give your code developed, we will put that code in our project and we will compile it and we will find out and tell you whatever the code that you have generated is working according to the logic or not. So you will be able to integrate the code that you have developed with our protocol stack code that we have available, and we will be able to, you will be able to find out whether your code, whatever that you have developed, is working correctly or not. So that is the practical part, that is the project part for the people who are choosing development. For the people who are choosing testing, you develop the test scripts, you will execute those test scripts, and you will analyze the log files and find out whether your test script is successful or failed. That way, for the people who are learning development, they will be developing a protocol, they will develop all the modules required in a protocol, and they will actually integrate that software with one of our protocol stack software and integrate it and see whether it is working correctly according to the protocol mechanism or not. You see, you're understanding that section, right? So that is for developers, right? Now, what about L2 L3 team, L2 L3 protocol? I've told you that first 14 to 16 sessions are going to be same for L2 L3 as well as LTE, right? So after the first 15-16 sessions, you're going to separate L2 L3 team. What L2 L3 team will be learning additionally? They will be learning advanced L2 protocols and L3 protocols only. That is the meaning of L2 L3, routing and switching protocol learning. Okay, so as part of that, what protocols they are going to learn is like STP, RSTP, MSTP, PVST plus, RPVST plus, VLANs, layer 2 VPNs, okay, LLDP, CDP, these kind of protocols we'll be learning. For switches, advanced switches, very big switches, not the switches that you see which are connected to your computer. There are going to be very big switches in the in a company big network. Those switches are going to be work on some special mechanisms, special protocols. So how those protocols work, we'll understand it at the protocol level. For L2, at L3 we'll be covering RIP, OSPF, EIGRP, BGP, ISIS. That is not there out in the listed in that part, but those protocols will be covered for IPv4 routing as well as for IPv6 routing. Then we'll be learning layer 3 VPNs, MPLS, IP security, multicasting, IGMP. These protocols will be covering in layer 3 level. These are called as advanced layer 2 and layer 3 protocols required for people who are going to do router software testing or switch software testing. Okay, are you clear with that for L2 L3? But for L2 L3, one won't be learning TTCN3, but they will be learning a scripting language called as Python, because for most of the L2 L3 companies will ask for not TTCN3, but they'll ask for Python. That is why you will learn Python. By using Python scripting language, you will understand how do you write these scripts to do the protocol testing. Okay. So people who are choosing L2 L3 protocol testing will learn Python and will write the test scripts to generate protocol testing scripts. But for the people who are choosing L2 L3 protocol development will go through the same modules. Like how do you generate protocol coder decoder? How do you generate protocol state machine, socket programming and protocol logic building by using one of the programming languages? But what is the difference between LTE protocol development and L2 L3? LTE protocol development people will be developing LTE protocols as part of the project. L2 L3 protocol development people will be developing L2 L3 protocols, routing and switching protocols as part of their project. Okay, concepts are same, but development protocol is going to be different. Even for testing team also, testing concepts, whether you do it with TTCN3 or Python, is going to be same testing concepts. But how do we do the testing? Okay, how do you do telecom protocol testing and how do you do L2 L3 protocol testing? Mechanisms are, the protocol mechanisms are going to be different. The protocol logic is going to be different. Logic is not going to be same. LTE protocol logic and L2 L3 protocol logic not same. They are different. They work for different functionalities. They are used in different environments. One is used in computer communications, other is used in telecommunications, datacom and telecom. Are we understanding this, guys? Now, the duration for L2 L3 is going to be around 2 months. Okay, duration is going to be 2 months, right? For L2 L3. For LTE, it's 3 months. It is going to be, because the theory part and the protocols are going to be very heavy for LTE. Now, will this LTE be part of embedded systems? Yes, we can call it as an embedded system design. Reason is, normally we use this embedded if we are talking about a particular type of system. What kind of a system LTE is? Telecom system. So obviously it can be classified as embedded domain. Normally, like embedded means what? One printer or one Xerox machine. You take any other systems which are working only for a specific purpose, it's called as embedded systems. From that definition, telecom systems also can be considered as embedded systems. Are we clear, guys? Now, the last section of this today's session, I have to introduce myself. My name is Banerjee. I'm having around 14 years of experience in telecom field, telecom and datacom field. I'm the one who is going to take you through these either L2 L3 sessions or LTE sessions. I know around 250 protocols. I have written protocol specifications also for 3GPP. I have majorly worked for a company called as Nokia Siemens Networks for about 10.5 years. Okay, and I have been working for TCLOUD for the past 3.5 years. Okay, 4 years, almost 4 years now. And at TCLOUD, we do develop these protocols, and we do develop these protocol stacks and telecom products, and we sell it to companies. Okay, we have already sold it to 2 companies, Wipro and Freescale. Okay, and along with that, TCLOUD's specialty is we do corporate trainings. Okay, we do all the trainings. For example, even for LVR also we do the trainings. If you would have observed it, for all LVR clients, we do the trainings in India because we are the training partners for them in India. You see, partners in India, right? So for all their trainings, we perform it in India, and that is my name out there. Okay, so we do TTCN3 corporate trainings, datacom corporate trainings, telecom corporate trainings. We do scripting language corporate trainings. All right, and when it comes to these courses, the complete material will be provided by us in the form of soft copies. Okay, it will be very, very readable. Okay, we'll be converting it into good PDFs and with valid points, and will be sent to you. Okay, after every session is completed, we'll be sending you the course content. So the full course content is our responsibility, but most part of L2, L3 or LTE, we will directly be referring to. Presentations are very less. Only for basic things we'll be using presentations. But once we go into the deeper concepts, we'll be always studying the specifications directly. Okay, the LTE specifications or IEEE specifications. We'll study that protocol specification and understand how that protocol works. Okay, the reason for that is, if we introduce the protocol specifications now itself, you will get familiar with those specifications. Once you started working in the companies tomorrow, okay, then it will become easy for you to work with those specifications, right? That is the reason. Otherwise, we would have made the presentations out of everything and we could use PPTs everywhere, but we don't do that. Okay. Yes, it will be part of that. Sharath, actually what and all the sections will be 4 sections, no, as part of it. For example, if you talk about this protocol state machine development, that will be containing the kernel logic as well. Okay, we'll be covering that part, Shant Kumar. These are the four divisions, but each one is going to contain subdivisions, which we'll be explaining at a later stage. All right. So that's all I have at this stage, but I have to introduce TCLOUD related tools in tomorrow's class. But for the next 10 minutes, I'm keeping this session open, even though it is 9:05, I'm little 5 minutes delayed. Okay, but still, if you guys have any questions, you can shoot out the questions directly. People who are sitting in front of me and the people who are attending it online, you can either type your question and send it to me in the chat box, or you can you can unmute your mic and you can ask your question. Yes. What we are going to do is, we are going to have 3 or 4 demo sessions, right? After the demo sessions, people will be decided to join or not to join. Okay, people think that this course is not suitable for them, or this guy is not teaching well, or whatever, you will be quitting. Okay, for the people who have decided to join, we are going to form a WhatsApp group. Okay, and that WhatsApp group will stay almost for after the course is completed also, to inform you about job related things. For example, we want your resumes, latest resumes immediately to send it to an interview. Who will be using that WhatsApp group? Okay, we'll be creating that WhatsApp group. All right, so you will be able to discuss in that WhatsApp group. Send one guy can actually ask a technical questions, others can answer it. Of course, I will be part of that WhatsApp group as well. If anybody is not answering the technical question, I will be coming in and answering it. Okay, so that WhatsApp group will be created. All right. We have around 50 to 60 companies in Hyderabad working on telecom area. Okay, starting from Qualcomm. Okay, you have got Tech Mahindra, you have got PrimeSoft Solutions, we have got TCS working on it, we have got Infosys working on it. We have got a lot of companies, lot of embedded companies are working on telecom. Okay, we have Nokia working on it and all that. Shant Kumar, our email ID is the same. My email ID, I will share it definitely. Okay, definitely I will be giving that email ID once we form the WhatsApp group. That is the first thing I do, to be able to send your queries to me directly. But right now, if you want to reach me, you can actually reach me on the same mail ID on which you have received the online link. If you have sent any mail on that link, automatically that mail will come to me. I will be able to reply to that. Okay. So, yes, totally we have around 250 telecom and datacom companies in India. And the prime location for datacom and telecom companies is Bangalore. Second location is Gurugram. Third location is Hyderabad. Fourth location is Chennai. Okay, these are the 4 locations in where major number of telecom and datacom companies are present. Okay, so you will be able to get the job in any one of the 4 locations. Okay, you can be specific also, and you can try to attend the interviews in one particular area. you can do that. Okay, you can target for it and you can attend the interviews. Shant Kumar, for the people who are in dilemma to choose LTE protocol or L2L3 protocol, you will have an option of 20 days. Within these 20 days, you will actually be getting a very sound knowledge on telecom and datacom fundamentals. And I will be giving in constant inputs about which one is better course for you, like LTE, or for what kind of people, which one is better. I'll be giving in constant inputs. So within these 20 days, you must be judging yourself to decide whether you are going to attend LTE or L2L3. I will be helping you out individually also. I'll be talking to you personally and I'll be helping you out individually and help out to make you take a decision on whether LTE is better or L2L3 is better. I will guess that, I will judge that, I will help you that on that particular part based on your previous career, what you are doing right now, what you want to do in the future, what is your present profile based on that. Okay. Just a minute, sir. Okay, somebody is asking a question. Kapil or Muthu, do you have the questions, guys? Muthu, I'm not getting you. Can you please type your question? Sorry. Kapil, do you have any question? All right. So, do you need any experience? Okay. Jobs are available for both kind of people, experienced people as well as freshers. Okay. For freshers, we will directly be taking the complete responsibility to forward the resumes and to, make the interviews happen. Okay. Reason is we have done the corporate training in telecom and datacom section in about 45 to 50 companies. Okay, so far. And we are maintaining very healthy relationship with those HRs wherever we do corporate trainings. And usually what happens is when they require fresher candidates, they will be approaching us. Reason is they know that we are #1 in India for telecom and datacom courses. And when we train them in their office and their premises for their projects, they know that we can train public people also. So obviously they will be taking interest in taking the resumes from us and filtering it and calling for the interviews and taking the interviews and selecting the candidates. Okay, so getting the jobs for the freshers is our responsibility, including resume preparation, forwarding the resumes to the companies and setting these interviews up. We will take the responsibility. But for experienced people, what do we do? Okay, experienced people, you don't need our help. What you are going to do is basically, we will help you in processing, making your resume, deciding what kind of a project you are going to keep for that resume, make you work on that project here itself in our lab, either it is a development project or a testing project. Okay, so once you work on it, you will get thorough knowledge on that particular project. You're going to include the same thing in your resume and apply it in Naukri Monster. You will be getting hell a lot of calls because there is a heavy demand right now for protocol testing. You will be getting a lot of calls. Within one day, usually our guys are getting around 20 to 30 calls. That huge demand is there right now. Okay, whoever has completed the course. Okay, and of course, most of the people are getting immediately placed. Okay, so you just have to attend the interviews and clear the interviews. And if you actually go through this particular session thoroughly, okay, you will be able to do that very easily. And one more option that I have to tell you is, if anybody is missing any sessions, okay, any moment in time, for example, you have got a personal work, you have missed the session, either online guys or direct guys, all these sessions will be video recorded and we'll be maintaining a backup of these sessions. Okay, so what you can do is the next day or the same day when you have the time available, you will be able to complete that backup session. So you literally won't be missing anything. Okay, so your sessions won't be missed at all. Yes, That part I'll be speaking to you, Shant, personally. I won't be able to tell that straight away. The individual questions will be there. I'll be talking to the people directly. Okay. So that's the part I have from my side. If you have any questions, you can. Okay. Good. Sindhu, okay. I just have to put that question of Sindhu for everybody, just to make everybody understand what the question is all about. Okay, by the way, I need to tell a little background on Sindhu. She is doing her MTech in JNTU, and we are associated with JNTU as well. We do decide the EC programs for JNTU. Sometimes we'll be setting up the things for JNTU. And JNTU has got a comprehensive program wherein people will be like going sent to Sweden, and they will be learning some things related to telecommunication and datacom related things. Okay. And she is doing she's part of such a program where she is learning network management and cryptography. Basically, the reason required for you to learn these things, network management is basically like a configuration kind of a stuff, which is basically required for any network. Okay. So in telecommunications or data communication, only the jobs won't be available on protocol development or protocol testing, but protocol maintenance also. That maintenance is nothing but your management. Usually the people who are doing CCNA, CCNP, CCIE kind of certifications, they will be working on network management. They are only to configure the protocols. They have to just oversee how the protocols are working. They don't care how the protocol is developed or whether the protocol is tested correctly or not. Okay, so all types of jobs will be available in the market, but our concentration will be on getting a job in R&D area, either in protocol development or in protocol testing. That is the primary jobs available in the market. The primary in the sense, very important jobs are the ones that are of highest caliber. Okay, there are various other jobs available in the market with lesser scope and not in R&D companies, working in maintenance companies. These things, network management related stuff is one such thing. Okay, even for that matter, cryptography. Okay, so there are many small pieces. It is not like that is the only thing, but our concentration is on that thing. What is that? Telecom protocol development and testing. You must be joining in a company like Alcatel-Lucent into R&D department, wanted to work on future telecom software, okay, before it released into the market. So you need to know what are the coming features in the market. So you'll be working on the modern protocols, modern features of telecom and datacom software. Okay, got that point, Sindhu? Both are not required, L2, L3 and LTE. Actually, both are two different domains. For example, Cisco majorly recruits the people for L2, L3 protocol development or testing, whereas Cisco won't recruit much for LTE. They have LTE project, they will recruit, but not as heavy as LTE, L2, L3, because Cisco's major market is routers and switches. 90% of the market is that. Only they are into 10% of LTE market. So the even recruitment levels also will be the same way. Okay, so but if you take other companies like Ericsson, or if you take Qualcomm will be recruiting, or Ericsson, if you take Ericsson will be recruiting only for LTE. Ericsson doesn't have any products in L2, L3 routing and switching mainly, so they won't be recruiting in here. Okay, so which area you are targeting, data communications or telecommunications? But if you wanted to keep both handy, if you wanted to learn both, you can join both, you can do that, but most of the times one will be enough. Okay, either LTE or L2, L3 to get the job. So you have to choose, but I will be helping you out in choosing. Okay, it never will be confused. You just have to be financially little sound in order to pay both the fees. That's all. Okay, but it will never be confusing. By the time we complete the datacom fundamental sessions, the first module, you will get a clear-cut idea about what is what. So there is no confusion from then onwards. Everything will be clear. You can join both the things, do both the things parallelly. You can include one datacom project, one telecom project, and you apply your resume in the internet as a telecom engineer plus a datacom test engineer. You can get a call from both the companies, interview call, because you are doing your work on both the projects. That is also possible. Okay, it won't be confusing, but you need to be able to put that little extra effort, okay, to learn both the things, because you need to be able to spare your time to learn both the things. All right, that's the only part, plus the money that you have to pay. Okay, 30,000 for LTE course and 20,000 for L2 L3. Which one? Billing related things, yes, we cover in LTE billing. Okay, we'll be covering that billing protocols called as GZ and GY interfaces, diameter related DCCA, diameter credit control application. We'll be covering those protocols, how those billing concepts work out. We'll study them. Yes. Yes, in LTE section. Yes, we cover mobile testing as well. Mobile testing is also, mobile is a component in LTE network. We'll learn every component testing, mobile testing, and there are other components in LTE network called as eNode B, MME, S gateway, P gateway, a lot of components are there. We learn to test every component. Every component is going to have some or the other protocol. We'll be learning how to test those protocols, including the protocols present in your mobile as well. Hmm. Hmm. It is, see, learning the subject is quite easy. Of course, it is not like self-pricing, but if you can actually join an institute like TCLOUD, we will be teaching you everything from very basics. Okay, is the today's session clear for you or not? If the today's session is clear for you, rest of the sessions throughout your course also will be the same way. If you can actually understand today's session, there is no point in telling that you cannot understand any of the sessions that are going to happen next. Okay, it is at the same level of complexity. Okay, so you will definitely be able to learn it if you have got good mind to understand today's class, right? That's the complexity level. But hard working is dependent on individuals, how good you learn, how well you will be able to, represent that when you go to the interview, whatever the knowledge that you have got. That skill you have to start working on, and you have to pick up that skill before you complete the course. Okay, that will help you out. Usually if you see in TCLOUD, they'll be forming small groups, and they'll be sitting together, and they'll be discussing interview questions, and they'll be talking about it. So they will do that kind of a preparation here. Okay, you can also be participating in such a group, and you can learn that skill to answer these technical questions. Okay, so that you will be able to do that very easily in your actual interview. All right, there's such kind of things. Kapil, for RF engineer, definitely I will suggest you, whoever is experienced in telecom, I will definitely suggest you LTE. I will never suggest you L2, L3. I will suggest you LTE, L3 only for the people who have done CCNA, CCNP and working on routers and switch configurations. That's all. If they are working on RIP protocol, OSPF protocol, these kind of things, no, then I will suggest L2, L3. For the people who are working in LTE or, LTE or 3G or 2G, as a BSS engineer or RF engineer or optimization engineer or any other engineer, a drive test engineer, for all of you, the only course that I would suggest you is LTE protocol. Testing. Kapil, it is testing, not development. You will not be able to learn C, C++ now, and you cannot claim that you have worked on C, C++ for 1 years, 2 years. That will become tough for you to learn one language, at the same time this telecom part also. So better we target first to get a job in testing, and then we go for development. People who are not involved in development earlier. But for the people who are already involved in development earlier, You can choose development. If you have good sound understanding on development concepts, how to do the development in C++, you already knew the syntaxes, function writing, everything, then you will be able, you can join development team. Otherwise, if you don't have that knowledge already readily available in your mind, you're fresh to it, better you'll be choosing testing, because in testing, whatever the scripting language you require to learn to write the scripts that we teach from the scratch, we'll be teaching you that scripting language. So you don't need to have any prior knowledge for testing. Okay. We'll be teaching you Linux. Hmm. Hmm. Python, yes. Yes, we'll teach that part. That interrelation between the scripting language and LTE, we teach that. Yes. Yes. Yeah. You cannot learn all the scripting languages. It's going to take infinite amount of time. Keep on learning, keep on learning. So what you have to do is you have to learn one, and you have to understand how the same implementation must be done on other scripting languages. You must be able to. I will help you out that part. Okay. Guys, I've taken too much time. Sorry for that, because a lot of questions are coming in. If you still have the questions, I will be calling you individually for the people who are attending online as well as the people who are directly sitting in front of me. So I'll be able to talk to you personally, one-on-one, and I'll be able to answer all your questions, whatever the queries you have got. But these demo sessions are going to be there for another 3 to 4 sessions. You don't need to pay. And once you are liking the whole thing about this course, you can actually join by committing. Okay, committing in the sense you have to pay your first installment and join, right? That's the thing you have to do, right? So if you don't have any questions right now, I'm going to quit this session. Tomorrow morning, online people, you will be able to use the same link again at 7:30 in the morning. First installment is going to be 10K, second is 10K, third is 10K. Basically, it is going to be 3 installments every month, 10K you're going to pay. Okay. Online people, you will be able to click on the same link tomorrow morning again, and you will be joining the session once again. Same, you will be joining the session automatically. Direct people will be coming in direct. Okay. Yes, you can attend online anytime, any day, no problem. Yes, you can. It is 7:30. The session will start, Shant Kumar. 7 a.m. Basically, session starting time is exactly 7:30. Okay. Online people can attend directly. Direct people can attend online. No problem. Whatever the way that you attend, no issues. If you're joined here or not, that's the only point. You can attend anyway. You can do the lab also in any way that you wish. No issues with that. Yes, you can do that. Yes, you can attend classes online. If you miss a class, we'll provide you that backup link, backup video. It will be available in our lab servers. You can connect to our lab server, attend that class. That's it. People who are directly coming in, you can sit in the lab and attend that session. Online people, you can connect to our lab server and attend that session. Okay, that's it. As simple as it. We'll announce the final timing for this batch once everybody is finalized and we form a batch. Of course, there are other people who have attended the same demo sessions earlier. They will also keep coming in. Once the full batch is formed, we will be announcing the final timing. Okay. Yeah, weekly 6 classes it is going to be starting with Monday to Saturday. Sunday will be off. Okay. Yeah, usually this is the time that's going to be fixed most of the time. Okay. Changes are there if it is normally 15 minutes, 20 minutes. Okay, here are there, depending on to, satisfy most of the crowd. That's it. Okay, it's a crowd basis mechanism. All right, guys. So that's it for me from now. Okay, sorry for the delay. I'm really, not in a position to stop that. Okay. Please come back to me and talk to me individually. Okay, if you have any questions, I'll be able to answer it. Right?